Hello, good morning, good afternoon, good evening, whatever time you are watching this video. Today we are going to start the topic complex number. Complex number. So let us have first of all little theoretical concept of this complex number in brief, and then we will go for the numerical part. So as you can see on the board, the complex number is in the form of a plus bi. A plus bi is the format of your complex number where a and b are actually the real number, and a is the real number part and bi is the imaginary part. A is the real number part and bi is the imaginary part of the complex number. Right? Now we will see some few basic properties of complex number. The first of all is a real number cannot be equal to imaginary number. That means in the complex number, the real number part cannot be equal to the imaginary part. Right? A is the real number part, bi is the imaginary part. Is it okay? So the real part cannot be equal to imaginary part. That is the first property. Second property is a complex number is zero. That means as a whole, this complex number is zero if the real number and the imaginary part, if the real part and the imaginary part, if these both are zero, then the complex number also will turn into zero. Then the last third property that we will see is the two complex number. Example, a plus bi and c plus di. Suppose if these are the two complex number, these two complex number will be said to be equal only when the real parts are equal and the imaginary parts also are equal. That means if a is equal to c and bi is equal to di, in that case the two complex number also will be said to be equal. Right? So with these few basic properties, we are going to begin some questions based on complex number. We are going to start question number 1 of exercise 21b. Here we are given some complex numbers, right? We are given a pair of complex numbers in each of the question, and we are asked to find the value of r plus s, r minus s, r into s, and r divided by s. So these are very simple questions. Let us see how do we do this question. So the first question that we are taking is Roman number 1. Question number 1, Roman number 1, right? Where question number 1, Roman number 1. Here the question, the first complex number we have is 3 plus 7i, and another complex number we have is I. These are the two complex number we have. So we are going to find the values of, first of all, r plus. This is r and this is s. This is r, sorry, this is r. This we can take as r and this we will assume as s. So we are now going to find the value of r plus s. Very simple. R is 3 plus 7i, and then s is simply I. Right? Now when we are adding this, it's very simple. We can add the imaginary part with the imaginary part and the real part with the real part. So here we have real part only as 3, and the imaginary part we have is 7i and then I. So the coefficient of these two will be added, and your answer is 8i. So 3 plus 8i is the answer for r plus s. Likewise, we can find the value for r minus s. R minus s, that means here r will be 3 plus 7i, very basic question, and then minus I. Once again, we have only the real part as 3, so that will remain as it is only. And then the imaginary part we have is 7i and minus I. The coefficient of these two will be simplified to 7 minus 1 will be equal to 6. This is answer. Now we will find the value of r times s. R times s. Now we have r as 3 plus 7i and then multiplied by I. Right? So this term we will multiply by this both the term 3 plus 7i. So when you multiply I by 3, it will come as 3i, and then when we multiply 7i by I, it becomes 7i square. Right? Now you know I square value is equal to minus 1. So this will be equal to, this is minus 7. So this minus 7 we can write first 7, and this will be plus 3i next. Right? In the order. Now next we have is, last one is r over s. R over s. Now once again 3 plus 7i and then divided by s. That is, s is I. Is it okay? Now when we simplify this, what we can do is, since we have the single denominator, monomial denominator, we can do the redistribution. So it becomes 3 over I, and this next will become 7I over I, right? As a result, what will happen is here this number I will be cancelled. So this will become, this imaginary part will become the real part. Therefore, we will write this as first, and then this is 3 over I, right? But in this imaginary part, this is imaginary part, but it is in the form of irrational number, because the imaginary part is not supposed to be in the denominator. Therefore, this part needs to be rationalized. So 3 over I we are going to rationalize. For rationalizing, we can multiply it by itself. Is it okay? We can multiply it by itself, and therefore your answer, this will come as equal to 7 as it is, plus 3 into I is 3I, right? And this I into I will become I square, and we know the value of I square. It will be equal to -1. Therefore, your complex number will be 7 minus 3I. This is the answer. Now we are moving on to question number 2. Question number 2, as you can see, the question says, solve each of the following equation for x and y. Solve each of the following equation for x and y. This question is going to be again a very simple question. By solving the given equations, we have to find the value of x and y. So from this question number 2, we are going to take part A, right? And then we are going to start. So question number 2, part A, the question we have is 2, part A. The question we have is x plus yi, one complex number, plus 3 minus 2i, and this is given equal to 1 plus 4i. So this is the condition given. Now by solving this, we are going to find the value of x and y. Is it clear? So let us open the two bracket. This is x plus yi, and this is 3 minus 2i. Right hand side as it is 1 plus 4i. Now when we are simplifying on the left hand side, we can add the real number with the real number and complex imaginary part with the imaginary part. So that way it becomes x plus 3. The real number are x and 3. So these two will be added together, and then we will add the imaginary part. Imaginary parts we have is yi and minus 2i. So from there, when we simplify this yi minus 2i, I can be taken out as the common factor. So inside we will have y minus 2, and then I is out, is equal to, on the right hand side as it is, 1 plus 4i. Now we can calculate the value of x and y by comparing the corresponding parts, right? So we are going to equate this x plus 3 with the real part, that is x plus 3 will be equated to 1, and simplify, we will get x is equal to 1 minus 3 is equal to negative 2, and this implies the value of x we got is negative 2. This is the value of our x. Likewise, we can compare the imaginary part and get the value of y. So y minus 2 will be equal to the coefficient of this I on the right hand side is equal to 4, and this implies our y will be equal to 4 minus 2 goes to the other side, the sign will change, it will become positive, and therefore this will be equal to 6. Therefore the value of y is equal to 6. Hope this question is very clear. Now we are moving on to question number 3. Question number 3, we have to find out the conjugate and the reciprocal of the given complex number, right? So we are given some questions in question number 3, and then we need to find out the conjugate and the reciprocal. So we'll see here how do we find the conjugate and the reciprocal, right? Now in question number 3, the first question that we have is I. This is the complex number. This is the complex number. We know that the notation of the complex number is z. So the complex number can be denoted by z, and therefore we are assuming this complex number to be z. And you know that the complex number, the format of the complex number is a plus bi, right? So we can write this here as 0 plus I. 0 plus I. Now this is exactly in the form of a complex number. This is the real part and this is the imaginary part, right? Now we are going to find out the conjugate first of all. The conjugate of this number we can write as z bar. This is read as conjugate of, right? And conjugate is very simple. Conjugate, what we can do is we just need to change the sign. We just need to change the sign and it will be called as conjugate. So here this plus will change into minus. Whenever we calculate the conjugate of this complex number, this sign will change. If it is plus, it will become minus. If this is minus, then it will become plus, and that is how we can write the conjugate number. So this is 0 minus I, and 0 minus I is basically equal to minus I. So this becomes the conjugate of our given complex number. Is it okay? Now we are going to find the reciprocal. Reciprocal. Our complex number is this. So reciprocal, to find out, we know that reciprocal means multiplicative inverse. Multiplicative inverse means when we write this number upside down, then that is read as complex number. Sorry, the reciprocal. So we are going to write the reciprocal of this given complex number as 1 over z. And your complex number is I. So this is the reciprocal. But now this reciprocal, in this reciprocal again you can see the I, imaginary part, is given in the denominator. Therefore this I in the denominator, it makes it a irrational number, and therefore we need to rationalize in order to get the complete reciprocal. So we will rationalize this. This is multiplied by I, this is multiplied by I, and then 1 into I will become I, and this I into I will become I square. And then we know the value of I square. The value of I square is minus 1, and therefore it will become 1 minus 1 into I, that is minus I. Is it okay? So here in this question, very fortunately, the conjugate and the reciprocal of the given complex number has come same. But it is not necessary that it will come always same. Is it okay? Now, let us calculate one more question. We will take one more question of question number 3. And that question we will take is number E. This was A. We will take E. Here the complex number we are given is root over minus 9 minus 1. This is the complex number. This is the complex number. Now, when I say this is a complex number, then you might be wondering that where is the I, where is the imaginary part? This imaginary part is hidden here. So from here we need to cultivate the imaginary part, and then we can complete the complex number. So let us first of all do the simplification. We can write this root 9 as root of 9 times root of minus 1, and this is minus 1 as it is. Now this is square root of 9 will be equal to 3, and you know the value of this part is equal to I. Therefore this is 3I minus 1, and therefore when we write this in the proper order, minus 1 plus 3I will become our complex number. So the complex number is z is equal to negative 1 plus 3I, right? This is the complex number. Now first thing that we have to find out is the conjugate. So the conjugate of this number, when we write, as I told you, that the sign of that imaginary number part will change. Then this will give you the conjugate. So we are going to write the conjugate of this given number as minus 1 minus 3I. This is your conjugate number, right? Now, after writing this conjugate number, we are going to write now reciprocal. Now we are going to write the reciprocal. A reciprocal of the given number. That means the reciprocal will be equal to 1 over z, right? Now this is yours, our z is, this is 1 over minus 1 plus 3I. This is the reciprocal. Once again, when we wrote the reciprocal, you can see here the imaginary part has gone in the denominator. That means this needs to be rationalized. So we will rationalize and we will get the reciprocal. So for this we will multiply the numerator and the denominator by the conjugate of the given complex number. So it will be negative 1 negative 3I over negative 1 negative 3I. As a result, in the numerator we will be left with minus 1 minus 3I, and in the denominator it is minus 1, and here also minus 1. This is plus 3, this is 3I, this is 3I. That means here this we can read as a square, a plus b into a minus b, a plus b into a minus b, and then this could be taken as the factor of difference of a square. So we can write the denominator in the form of difference of a square. So it becomes minus 1 square minus 3I square. Is it okay? Now, as a result, in the numerator will be as it is, only minus 1 minus 3I. Denominator, this minus 1 square will become positive, so this is 1. This is minus sign, and this is 3I square. 3I whole square. That means 3 square will become 9, and I square will become I square, right? we know the meaning of I square. I square means it will give you minus 1. That minus 1 and this minus sign will make this as positive. So therefore, this will reduce to minus 1 minus 3i divided by 1 plus 9. This becomes 1 plus 9. And therefore, this will be equal to minus 1 minus 3i divided by 9 plus 1 is 10. So this is the result. But now we have to write this in the form of a complex number. That means the imaginary part and the real part and the imaginary part has to be separated. And therefore, finally, when we do the redistribution, we will get it as minus 1 over 10 and then minus 3i divided by 10. This is the reciprocal of the given number. Next, we are taking question number 4. Question number 4, you can see there are 4 parts in question number 4, A, B, C, and D. Now, in all these questions, we have to simplify. This is just to simplify. So, let us see one by one how many questions we can take. This is question number 4. Let us take first of all part A. In part A, the question is 3 minus 7i, and this is just to simplify. Now, with this basic concept of algebra, just with little bit concept of algebra, we will be able to solve all the questions of question number 4, right? Now, as you can see on the board, the question is 3 minus 7i whole square, right? Now, this square sign, this indicates that this is a perfect square. So, we can use the expansion of a minus b whole square. And by expanding this, we will get the solution. So, this we can simplify. We can use the a minus b whole square formula. The formula is minus b whole square formula. Expansion is a square minus 2ab plus b square. Once again, I repeat, a square minus 2ab plus b square. So let us use that expansion. A square means 3 square and then minus 2ab, that is this into 2. So 7 3 is 21 into 2, 42. 42i and then square of second term, that is 7i square, that means 7 square means 49 and then I square means I square simply. Is it okay? Now, this first term, this 3 square will turn into 9. This middle term will be as it is 42i. And the last term, this is 49i square. You know, I square value is minus 1. This is 49. And then I square means minus 1. So, when we simplify, this will come as 9. And this 49 into minus 1 will become minus 49. And that minus 49 will also become the real number. Therefore, it can be written with 9. So, minus 49i. And sorry, minus 49 simply. And then the last term is minus 42i. Now, when we simplify this to a like term, so they can be simplified. 9 minus 49 will come minus 40 minus 42i. This is the answer. Is it very clear? Now, let us take one more question, that is number B. Question number B is negative 1 over 2 minus root 3 over 2 I and then the whole square. Now, this question also is same as the first part, part A. We have this is whole square sign, whole square power, right? That means this can be read as a minus b whole square. Is it okay? A minus b whole square. Only there is a little bit of problem that normally whenever we have seen a plus b whole square or a minus b whole square, now we have seen this always as either a plus b whole square or a minus b whole square. That means middle sign has been either positive or it has been negative, right? But this is the first question where we see both the terms are negative. Is it okay? So when both the terms are negative, ultimately then this everything will turn into positive, right? What is the concept? How it becomes positive? I'll show you. What we can do is from this given bracket, we can see the minus sign is common in these two terms, right? So we will take out this minus sign as common factor. Minus sign is taken out as the common factor. Now, when this minus sign comes out, the same power will be also applicable to this common factor, right? So therefore, we will square it. And then inside, now because we have taken out the minus sign as the common factor, so this term will turn into positive and this also will turn into positive. So we can write this as 1 over 2 plus root 3 over 2i whole square. Now you can see here, the base is negative, but the power is even number. So ultimately this will turn into positive, no? And that is why I told you that if both the terms are negative, then automatically the term becomes positive. So therefore, finally we have this our expression as 1 over 2 plus root 3 over 2 I, and then this is whole square. Now we can expand it and then solve. A square, that means the square of 1 over 2. This means it will become 1 over 2 whole square. Then middle term plus 2 into this. So 2 into half into root 3 over 2 I, and then the last term is the square of the second term. That is root 3 over 2 I whole square. Is it okay? So now we can simplify. In the next step, this 1 over 2 whole square will become 1 over 4. This 2 and this 2 will be cancelled. So finally we get this as plus root 3 over 2 I, and this will turn into root 3 square will become simply 3, 2 square will become 4, and I square will become I square, right? I square. In the next step, what we can do is this I square will give you value equal to minus 1. Therefore, we can introduce minus 1 for this one, I square, and then multiply it by 3 over 4. So that 3 over 4 will become simply negative. Then this 2 will become the real part, and we can simplify. So it will become 1 over 4 minus 3 over 4, and this will remain as it is, plus root 3 over 2 I. Now when we simplify this 2, because their denominator is same, so we can have a common denominator, that is 4, and a numerator will be easily simplified directly. So 1 minus 3 will become minus 2. So this is minus 2 over 4 plus this is root 3 over 2 as it is, and then this is I. Now in this we can see there is the two number, numerator and the denominator can be divisible by a common number, that is 2. So we will simplify and reduce this, and the final answer will be minus 1 over 2 plus root 3 over 2 I. This is our final answer. Clear? Next question we are taking is question number 5. In question number 5, you can see we are given some mathematical statement, right? And then we have to find the value of x and y for which the given statements are true. So find the real values of x and y for which the given statements are true. So we are going to do it by calculation. We will simplify and then we'll find out the values of x and y. That's all. So first of all, we are taking this question number 5a. 5a. The question is x plus y over I, right, plus x minus y plus 4 is equal to 0. Now we are going to start with this question. Now what you can see here is in this equation we need to modify first of all this equation, and then same time we will do the rationalization of this part, because this part is a rational number because the imaginary number is gone in the denominator. So what we can do here is, for rationalizing, x plus y will be okay, and this is I. The numerator and the denominator will be multiplied by the conjugate of this number. So this is plus I, that means minus I divided by minus I. Then the other part will be as it is, x minus y, and this 4 we will shift to the other side, so it becomes minus 4, right? As a result, in the numerator we see this as x minus sign here, and this is x plus y I, and in the denominator we have minus, plus minus minus, and then I into I square, and then this is x minus y is equal to negative 4. Now we know, this is I square, we know the value of I square is minus 1, so this minus sign and this minus sign will make it positive, but ultimately this sign will remain negative because altogether here there are 3 negative signs. One, this negative sign, and the second negative sign, and the third negative sign will come from here. So since the number of negative sign is odd in number, therefore this part will remain as negative. Therefore we can write this as negative x plus y I, and then plus x minus y is equal to negative 4. Negative 4. Is it okay? Now here what we can do is we will equate the corresponding parts. We will equate the corresponding part. So here with this imaginary part, this I is mine outside. Very sorry, this I is mine outside. I is mine outside the bracket. So this is the imaginary part and this is the real part. So real part will be equated to the real part and imaginary part will be equated to the imaginary part. Now on the right hand side, we can see that we have only the real part. Therefore, this x minus y will be equated to minus 4. X minus y is equal to negative 4. This is our first equation. and the imaginary part, that is x plus y, will be equated to the imaginary part. That's why there is no imaginary part. That means the imaginary part is equal to 0. Therefore, this minus x plus y will be equated to 0. Since we are equating this coefficient of I with 0, therefore the minus sign will have no value because minus sign will go to the other side, and your equation will finally reduce to x plus y is equal to 0. So now we got these two as the simultaneous equations. We got these two equations in two variables. We can solve it by elimination method and find the value of x and y. So we are directly going to simplify, because as you can see here, the coefficient of y, one is negative, one is positive. So we can simply cancel it, and then this we can simplify. This x plus x will become 2x minus 4 plus 0 is equal to minus 4, and this implies the value of x is equal to negative 2. Minus 4 divided by 2 will come negative 2. Now we can find the value of y. Maybe for naming, for convenience, we will name this as equation number 1 so that we can use it. So now putting the value of x in equation number 1, right? We get this as, for x we will place as minus 2, and this is minus y is equal to minus 4, and this implies our minus y will be equal to, right hand side is minus 4, this minus 2 will become plus 2, this is plus 2, and therefore the answer is minus 2. Now minus sign and minus sign is cancelled. So finally our value of y is equal to 2. This is the value of y, and this is the value of our x. Hope this question is clear. Next we are taking question number 5b. Right, here also we'll find the value of x and y. So let us start simplifying. Left hand side, this is the imaginary part, this is the real part, right? But on the right hand side we can see we have the imaginary part, but it is given in the form of irrational number. So first of all we need to rationalize the right hand side, and then we can operate to find the value of x and y. So here itself we will start. We will multiply the numerator and the denominator by its conjugate. So this is minus I, and this also is multiplied, numerator also is multiplied by minus I. As a result, in the numerator we will get this as minus 8i, and then in the denominator this I and this I, this minus sign will remain here, and then I into I will become I square. And you know the meaning of I square, the value is of I square is equal to minus 1. So that minus 1 and this minus 1 will make it positive. So ultimately we will be left with minus 8i, because the denominator will become 1. Therefore we don't need to write denominator as 1. So our equation is now left hand side is equal to minus 8i. Now we can find the value of x and y by equating the corresponding terms. So we are going to equate the real part to the real part and imaginary part to the imaginary part. In this question we can see here, right hand side we have only the imaginary part. That means this real part, when you are equating to the other side with the other side, it will be equated to 0 because the real part is equal to 0. So the first equation we will have here is 2x minus y plus 3 plus 1 is equal to 0, right? And this part will be equated to the imaginary part. So this is equal to minus this coefficient of this I is minus x plus 3y, and the coefficient of this I is minus 8. So when we equate this part to this part, the minus minus will get cancelled, and finally our equation will be x plus 3y is equal to 8. Now this is equation number 1 and this is equation number 2. Now here we need to modify one thing, is because our constant in one of the equation is on the right side, in the first equation it is on the left hand side. So better to have this also on the right hand side. This will become equal to minus 1. When this plus 1 goes to the other side, it will become minus 1. After this, now we can solve it by elimination method. So choice is ours, what we can do. So in my opinion, we can multiply this equation by 3 so that the coefficient of these two equations, coefficient of y, becomes same in the two equations. So the first equation will reduce to 3 2s are 6x, and then this is minus 3y, and this is minus 3. Now we are going to add it. So there is no need of change sign. This is cancelled. This is 6x plus x is equal to 7x, and this is 8 minus 5. It will be equal to 8 minus 5 is equal to 8 minus 3 is equal to 5. This implies our x will be equal to 5 over 7. This is the value of our x. Is it okay? Now we will calculate the value of y. For calculating the value of y, we can either put it in equation number 1 or in equation number 2. So I am going to put it in equation number 1. So putting the value of x in equation 1. We are going to put the value of x in equation number 1. So for this x, we are going to put the value as 5 over 7. Let us do that. 2 times for x is 5 over 7. 5 over 7 minus y is equal to minus 1. Now when we simplify, what we can do is y we will take to the other side and minus 1 will bring to the left side. As a result, this y will become positive. This minus 1 also, when it comes to this side, will also become positive. So ultimately the value of y will be equal to 2 5s are 10 over 7 plus 1. Right? When we simplify, this comes as equal to 17 over 7, and therefore the value of y is equal to 17 over 7. The value of x we already calculated before as 5 over 7, and the value of y we got it as 17 over 7. Now we'll take one more question of question number 5, that is number D. Right? We have to find the again value of x and y. So first of all, let us simplify on the left hand side. As you can see, it is given as 2 root 3 cos of 30 degree minus 2i sin 30 degree divided by root 2 times cos 45 degree plus I sin 45 degree. Now these are the angles which are very comfortable. We know the value of all these trigonometrical ratios for this given angle. So therefore let us write the values and then simplify. This is 2 root 3 as it is. Cos of 30 degree is equal to root 3 over 2. Is equal to root 3 over 2. We know the value. Minus 2i. Sin 30 degree value is equal to 1 over 2. The value of this is given as 1 over 2. Sin at 30 degree is 1 over 2 divided by, this is root 2, and cos at 45 degree value is 1 over root 2 plus I, and then sin at 45 degree also the value is 1 over root 2. Right hand side as it is, x plus y I. Now we can see here this 2 is cancelled, this 2 is cancelled. Right? Now when this root 2 gets inside, right, it will be multiplied by 1 over root 2, and this will be also multiplied by this 1 over root 2i. Therefore this root 2 will be cancelled. So this will be equal to, now this in the numerator we have root 3 into root 3 will become 3, and this is simply minus I. Denominator, this will turn into 1, and this will turn into simply I, and right hand side we have x plus y I. Is it okay? Now in this case we cannot have this imaginary part in the denominator, so we will rationalize it. This left hand side will be rationalized. So for rationalization, we will multiply the numerator and the denominator by the conjugate of the denominator. Therefore, it will be 3 minus I divided by 1 plus I, and the conjugate of this is 1 minus I divided by 1 minus I. On the right hand side we have is x plus yi. Right? Numerator we can multiply. Then the numerator will reduce to 3 times 1 is 3. 3 times minus I is minus 3i. Then minus I into 1 is minus I. Then minus plus, and I into I is I square. Denominator, this will be a plus b into a minus b. That means a square minus b square. A square means 1 square. 1 square means 1. Minus I square, I square. Is it okay? And right hand side we have is as it is, x plus y I. Now this implies what happens is, now we can see here, this in the numerator, I square will turn into minus 1. So this will become, this I square will become real number. Means this 3 and this minus 1 can be simplified. So 3 minus 1 will become 2. Minus 3i and minus I will become minus 4i because they are also like term. Now in the denominator, 1 square is 1, and this minus sign, and I square is equal to minus 1. So that minus 1 and this minus sign will make it plus. So therefore 1 plus 1 will become 2, and this is denominator is 2, and this is then equal to x plus yi right hand side as it is. Now in the numerator we can see, we can either say we can do the redistribution or we can take out the common factor 2 from the numerator. Then finally your equation on the left hand side will reduce to 1 minus 2i, and then right hand side we have is x plus yi. Now very easily we can find the value of x and y by equating the real part to real part and imaginary part to imaginary part. Therefore this x will be compared with the imaginary part, real part. So therefore the value of x will be equal to 1, and imaginary part will be compared with the imaginary part. So y will be equal to minus 2, y is equal to minus 2. This is the answer. Clear? Now we are moving on to question number 6. Question number 6 is very simple question. We just have to find out the conjugate. Write the conjugate of 6 plus 5i whole square. Right? So let us see how do we do this question. Question number 6, Roman number 1. Question number 6, Roman number 1. Roman number 1. The question is 6 plus 5i whole square. 6 plus 5i whole square. 6 plus 5i whole square. This is a complex number, right? So we can denote it as z, right? This is our question. Now the question is to find out the conjugate. Conjugate means z bar. This is read as conjugate, right? So to find the conjugate of this complex number, first of all we need to simplify this complex number, right? This complex number is given in the form of a plus b whole square. So let us expand it. A plus b whole square we can apply. A plus b whole square means a square plus 2ab plus b square, right? We need to be mindful. This is 6 square, then plus 2 into this. So 6 5 is 30 into 2, 60i. And then square of the second term, that is 5i square. Right? Now let us simplify. This is 6 square will be 36. And then we will have 60i. And then last one is 5i whole square. That means 5 is square means 25 and then I square. So 25 I square. Now we know the value of I square. This can be replaced by minus 1. So this function is equal to 36 as it is. Then this is 60i and then this will become minus 25 because I square will turn into minus 1. So this is minus 25. Now these two are real number. These are like terms, so they can be simplified together. It will come 11 plus 60i. Is it okay? Now we can have the conjugate. We finally got the complex number, so the conjugate of this will be is equal to 11 minus 60i. Is it clear? Now let's see question number 6, Roman number 2. What the question says: find the real numbers x and y if the product of these two complex number is the conjugate of minus 6 minus 24i. That means the product of these two is equal to the conjugate of this number, right? This is the meaning of, this is the instruction, right? Find the real number if the product of this is the conjugate of this one. That means the product of these two is equal to the conjugate of this one, right? So let us know first of all what is the conjugate of this number. The complex number we have is z is equal to minus 6 minus 24i. This is the complex number given, and then this implies the conjugate of that number, it will be equal to, thus this sign will change, no? That is called as conjugate. So it will become minus 6 plus 24i, right? Now, according to the question, the product of these two complex number is equal to the conjugate. If this is so, then find the value of x and y. So, according to the question, what the question says is the product of these two is x minus yi times 3 plus 5i. The product of these two number is equal to the conjugate, that is minus 6 plus 24i. Now this is the condition, according to the condition. Now find the value of x and y. So it's very simple. We will multiply these two complex number, and after multiplying, then we can equate the corresponding terms and get the value of x and y. So let us multiply this left hand side. X into 3, 3x. 3x. Then x into 5i means 5xi. Then 3 into minus yi. So minus 3yi. And then minus yi into 5i. It will become minus 5yi square. This is equal to minus 6 plus 24i. Right? Now we can see here this I square will change into -1, will give you -1. So with this -1 and this -5y, it will make it +5y. So this will become the real number. And this is another real number. So we can put these two together and these two can be together. Right? So let us write it, rearrange. This is 3x. This is 3x. This will become 5y. And then we can have these two together because these two are the imaginary part. So we can write this as 5x and then minus 3y. We have taken out this I as the common factor, I, and this is equal to -6 plus 24i. Right? Now this is the real part, this is the imaginary part. So these two parts can be equated with the corresponding element. So equating the corresponding element, we get 3x plus 5y is equal to -6. We can name this as equation number 1, and imaginary part we can equate. This is 5x minus 3y is equal to 24. This is our equation number 2. Is this very clear? Now after this we can solve this two equation by elimination method and we can simplify. So we can make the coefficient of y same. For that we can multiply this equation by 3 and this equation we can multiply by 5. Therefore, the coefficient of y will become same and this can be eliminated. So, the equation 1 and 2 reduces to, equation number 1 will become 9x plus 3 5s are 15, y is equal to -18. Equation number 2 will become 5 5s are 25, x 5 3s are 15 minus 15, y is equal to 25 5s are 120. Right? Now we are going to simplify. So this will be cancelled. This 25 and then 9 will become 34x and this side will become 102. Is it okay? Now when we simplify, this x will become equal to 102 divided by 34 and this will be equal to 3. So we got the value of x as equal to 3. Is it okay? This is x is equal to 3. Now we can find the value of y by putting this value of x either in 1 or in 2. So we are going to substitute this in equation number 1. On substituting the value of x in equation number 1, we will get what? See, 3 times x value is equal to 3 plus 5y is equal to -6. Now this is 5y is equal to -6 and 3 3s are 9. 9 will go to that side, will become negative. This will be -9 and therefore y is equal to -15 divided by 5. This is equal to -3 and therefore the value of y we got it as -3 and this is the final solution. So the value of x we got is x equal to 3 and value of y we got is y is equal to -3. Question number 18. This question is again very simple. This question is just express the given number in the form of a plus bi. Express this as a complex number, meaning express this given number as a complex number. Means express the given number in the form of a plus bi. So we are going to start calculation. We are going to start simplifying this. What we can do is, as we can see, first of all, in the denominator we have imaginary number. So this need to be rationalized and then we can try. We will start. This is 5 times 2 plus I and then denominator is 2 minus I. Now when we are rationalizing it, we have to multiply the numerator and denominator by the conjugate of this number. That is 2 plus I divided by again 2 plus I. Right? So now see what happens. With this, if you look at the numerator, in the numerator we got this 2 plus I and 2 plus I. That means this will become 5 times 2 plus I whole square. Right? Whereas in the denominator, this is a minus b and this is a plus b. That means this will change in the form of difference of a square. So we can write the denominator in the form of difference of a square. It will become 2 square minus I square. Right? Now, and then this is the root. Next, what will happen is this 2 square, okay, 5 and then this is 2 plus I whole square. Just now we will keep it as it is. Denominator, this 2 square will become 4. This is minus, and I square value is equal to minus 1. So this is minus 1 root over. Now we can see what happens here. Okay, this is now this is square and this is square root. For 2 plus I, the root sign will disappear. Only for 2 plus I, the root sign will disappear because we have the square, and then that square and square root will cancel for 2 plus I. For root 5, it will remain under the root sign because 5 is not a square number. Denominator, this minus 5, minus 1, and this minus will become plus. So it will become 4 plus 1. Then the equation, the function reduces to 5, and then denominator also will be 5, and then the rest part 2 plus I whole square will just remain as 2 plus I. Right? Now this and this is same, so this will be cancelled, the number divided by itself, and therefore our answer is 2 plus I. Is it okay? Now finally our function, our given expression is expressed as a plus bi. Is it okay? Now we will take one more question from here. This is Roman number 2. We will take this as the question is Roman number 2. The question is 3 minus I whole square over 2 plus I. Now this question also we have to express this as a plus bi in the form of a plus bi. So let us start. Now first thing that we will do here is this numerator 3 minus I whole square will be expanded using the expansion of a minus b whole square. Using the expansion of a minus b whole square. Where at same time this denominator, that is 2 plus I, which is in the form of an irrational form, in the form of an irrational number, will be rationalized, right? So we are going to do that. First of all, let us operate the numerator using a minus b whole square. So a square means 3 square minus 2 into this, that is 6i, and then plus I square. And the denominator we have is 2 plus I, right? Now same time we are rationalizing it also. So we will multiply the numerator and the denominator by the conjugate of this number. So it will be 2 minus I and then divided by 2 minus I. Right? Now this 3 square will become 9 minus 6I, and this I square will become minus 1. So this is minus 1, and then divided by this denominator will become a square minus b square, because this is a plus b and this is a minus b. So we can write this in the form of difference of a square. So we'll have the square of 2 and then minus, then square of b, that is I square. And then in the numerator these two are operated. Now still we are left with 2 minus I. So this we will write as it is 2 minus I. Now in the numerator what happens is 9 and then minus 1. These two are real part in the bracket. So this will be operated, simplified together. It becomes 8 minus 6I, and then we have 2 minus I. Denominator, this is 2 square, it will become 4, and this is minus I square means minus 1, and then this minus sign will become plus 1. Now we can multiply the numerator. So this is 8 into 2, 16. 8 into minus I is minus 8I. Minus 6I into 2 is minus 12I. And then minus 6I into minus I. Minus will become plus. And then 6I into I will become 6I square. Denominator, we will have 4 plus 1 as 5. Now this is equal to, now you know that I square will be equal to minus 1. I square will be equal to minus 1. So this will become, this 6 will become minus 6. Right? And this will become real part. So 16 minus 6 will become 10. And then minus 8I and minus 12I. These two are the like terms, so they will be added together. This will become minus 20I divided by 5. Now in the numerator we can see there is a common factor, that is 5. So we can take it out. This will become 2 minus 4I divided by 5. And this 5 will be cancelled. Finally our answer will be 2 minus 4I, and this is how the given question is converted in the form of a plus bi. So with this we are ending this exercise. Thank you so much for watching the video.